Good morning, all. Thank you, moderator, for the time given to me. I am Baharuddin, representing the authors of this paper as the presenter. Well, the paper presentation is entitled Performance Analysis of Diversity Selection Combining Technique in Rayleigh Fading Channel. On channel wireless, fading and noise are some of the factors that can decrease the performance of communication system. Fading can cause the information signal loss, and noise can cause the signal 0 change to 1 and signal 1 change to 0. So, to solve the problem, diversity selection combining on wavelet domain is used. While diversity selection combining is used to improve the performance of radio channel without increasing the transmission power. In this research, the system is designed by using diversity selection combining that works on wavelet domain. The design system of this research is seen on the diagram. The transmission image is a grayscale of Lena image. Before compressing the image is decomposed. With a wavelet transform, the output of wavelet transform on image is compressed with the SPIHT algorithm, which resulting bit stream. The output of the SPIHT algorithm become the input of RS encoder and modulation KPSK. The output of RS encoder is then modulated KPSK before it is transmitted to the wireless channel. Then, the bit stream image is transmitted to wireless channel. To see the system performance, the SNR value is given from 10 dB to 20 dB. The receiver captures two signals that are independent on fading and noise from the transmission channel. From the output of the KPSK demodulator, the bit sequence is converted to decimal form for the input from the RS decoder. The decoder process of RS decoder produces bit stream that has minimum error. In the system, the combination of blocks is used by selecting the best blocks from the two transmission channels. By using diversity selection combining, the bit streams received from the uncorrelated diversity channels are divided into blocks and compared on a block-by-block basis. For each new block, the coefficients of the composite wavelet transform are updated based on the received bits. If the coefficients reconstructed from one block are judged more likely, then all of the coefficients from the more likely blocks are placed in the composite wavelet transform. If all of the chosen coefficients blocks are error-free, then the reconstructed image will be error-free. Two blocks based by diversity rules were developed. The first block-based diversity rule only select blocks of bits from one bit stream based on a measure that is independent on wavelet transform characteristic. For each new block, the coefficient of the combined wavelet transform is updated based on bits received. To evaluate the system performance of diversity selection combining in Rayleigh fading channel, several experiments were carried out to test the BER and PSNR value result on both image with a compression ratio of 0.4 bpp. This table represents the comparison of DSC performance on wavelet domain in Rayleigh fading channel with rate 0.4 bpp, with SNR 10 dB to 20 dB with and without diversity selection combining. From the table, the system with diversity selection combining shows that there was 13.4% in average the reduction of BER value compared to without diversity selection combining, and also the PSNR value had an average increase to 2.2 dB. The result of the experiments, which were carried out to test BAR and PSNR on the both image with a compression ratio of 0.4 bpp with diversity selection combining in Rayleigh fading channel, showed that there was 13.4% in average the reduction of BAR values compared to without diversity selection combining. The PSNR value also had an average increase to 2.2 dB. The results of this study shows that the use of diversity selection combining techniques in the wavelet domain can reduce errors and improve the quality of image reconstructions. Thank you.